The most terrifying thing about a praying mantis is not that the female sometimes devours her partner. It's that after losing his head, his body keeps mating, driven by automated nerve clusters. But this is just one command in a 300-million-year-old biological code. This creature is a master of deception, hiding in plain sight with advanced 3D vision, tracking its targets like a military guidance system. And it doesn't just stop at insects. When a mantis locks its target, it can systematically slaughter and eat the brains of vertebrates its own weight, like lizards, mice, and even hummingbirds. You are about to enter the domain of nature's most cold-blooded trap. Let's begin. The most terrifying thing about a praying mantis isn't even that the female sometimes devours the male. It's that after losing his head, his body continues to mate. The myth that the female always bites off the male's head is exaggerated. In nature, this occurs in only 13 to 28% of cases. But if it does happen, a biological horror unfolds. The female's jaws first pierce the thin area between the eyes and the thoracic segment. The chitin doesn't crack immediately. First, it bends. Then it snaps with a short, dry click. The head detaches. The antennae are still moving, but the body does not stop. The nervous system of a mantis is built differently than that of vertebrates. His body is not managed by a single control center. Separate nerve nodes, ganglia, are located along the abdomen and chest. Tiny, autonomous stations. Each one can trigger its own chain of movements. And sometimes, the brain only gets in the way. After decapitation, the inhibitory signals vanish. The body is literally unleashed. The abdominal muscles keep contracting. The genitalia remain locked. The front legs hold the female. The male is already dead. But his organism operates for several more minutes like an automated system whose main processor was ripped out, while the backup programs remained active. Sometimes the female begins to eat him right during mating. First the head, then the thorax. She holds the body with her spiky legs and slowly slices through the tissue with her mandibles. The mantis's jaws move sideways like miniature bone cutters. They don't tear, they slice, muscle by muscle. The male at this moment keeps moving as if nothing happened. His legs still clasp the female's body. The abdomen continues its rhythmic motions. Pale, nearly transparent hemolymph, the insect version of blood, slowly leaks from the severed neck. Physically, the body does not yet realize that the head is gone. Cannibalism in mantises is not cruelty. It is a survival mechanism. And for them, it is normal from birth. Newly hatched, tiny nymphs immediately begin to eat each other. In the world of the mantis, the kindest do not survive. The fastest and most precise do. Sometimes only a few minutes pass after hatching before the first slaughter begins inside the egg case. Hundreds of tiny bodies emerge almost simultaneously. They are still translucent, soft. Their chitin has not yet hardened. Their limbs tremble after molting. But the program is already running. One nymph accidentally touches another with an antenna. An instant turn of the head, motion-locked, a strike. The front legs are still small, but they operate on the exact same blueprint as the adults. Spikes drive into the neighbor's abdomen. The thin membrane tears. The insides are pulled out in whitish threads. Other nymphs sense the movement and the scent of damaged tissue. Within seconds, the egg case turns into a cramped arena. Some try to crawl out. Others are already eating their brothers right inside the shared nest. Some have their limbs torn off before their very first step. Someone loses a head. Someone keeps crawling even after half of their body is gone. And all of this happens in absolute silence, without emotion, without rage, simply the execution of an ancient biological code. And this is only the beginning. The mantis looks like an ordinary insect, but its behavior resembles a predator operating on pure reflex. Over hundreds of millions of years of evolution, its design has barely changed. The blueprint proved too effective. Its hunt functions as a sequence of short commands. Detect movement, calculate distance, lock the angle, build up pressure, fire the legs, secure the prey, begin to eat. The strike of a mantis is so fast that the human eye is virtually incapable of seeing it. About 25 milliseconds. That is dozens of times faster than a blink. But the mechanics of the strike are even more sinister. Before the attack, muscles inside the chest slowly contract like cables being tensioned. Elastic energy accumulates in the joints. The base of the legs is locked by a specialized mechanism. For a few seconds, the mantis can remain completely motionless, and then the latch releases. The limbs launch forward almost ballistically. This is no longer a leg movement. This is a shot. The forelegs accelerate so violently that the prey often fails to even initiate a flight response. A fly still sees the flower. A fraction of a second later, it is trapped between the spikes. On the inner side of the legs are long, chitinous needles. When the legs snap shut, they don't just hold the victim, they impale it. The spikes enter between the body segments, hook into the soft tissues, and block all movement. The insect still tries to break free, but every muscle contraction only drives it deeper onto the needles. Sometimes the prey literally impales itself. And the most unsettling part, the victim often remains alive the moment it is already being eaten. For an ambush predator, speed is more important than humanity. A fly twitches in its grasp. A locust kicks its hind legs. A beetle tries to open its wings. But the mantis is already bringing the prey to its jaws. First, it chews through the softest areas, the eyes, the segment joints, the neck. If the prey is large, it can hold it in its legs for hours, slowly ripping off pieces of flesh with its mandibles. The jaws work rhythmically, calmly, almost mechanically. Sometimes the prey is still moving while its head is being hollowed out. Sometimes the mantis deliberately starts with the nerve centers, not to kill faster, but to make the prey stop resisting. This is exactly why they are capable of hunting dangerous creatures: wasps, hornets, spiders. The mantis rarely attacks them head-on. It waits. It observes. When a wasp lands and begins to fold its wings, its body loses mobility for a second. That is the exact moment of the strike. The legs pin the thoracic segment before the insect can deploy its stinger. With hornets, the mantis often grabs the area right behind the head, where the chitin is thinner, and it is harder for the opponent to reach with its sting. With spiders, the situation is even worse. Some spiders can kill a mantis with a single bite, but the mantis uses the length of its limbs as a ranged lock. It literally holds the spider at arm's length while slowly chewing off its legs one by one. The web vibrates. The spider tries to turn. Fangs snap in a vacuum. But the mantis has already calculated the angle. It isn't even the mantis's speed that frightens. It's how it sees the world. This is the only known insect with full stereoscopic 3D vision. But it works differently than a human's. The mantis determines depth not by the shape of objects, but by movement. Freeze! And to him, you virtually vanish. Its brain saves resources as strictly as possible. No useless details, only movement, only potential prey. Scientists put miniature 3D glasses on mantises. The insects successfully attacked virtual flies on a screen. Effectively, their visual system can calculate distance even to an artificial target. Now, engineers study this vision to build autonomous robots and computer vision systems. There is another reason why mantises seem so uncanny. Their compound eyes create a pseudopupil effect. Therefore, it appears as though the mantis is constantly staring directly at you, even when you move. In reality, you are seeing a dark zone where light is not reflected back, but the human brain perceives this as a gaze. Cold, unmoving, watchful. Furthermore, it is the only insect capable of turning its head nearly 180 degrees, and it does so slowly, without jerks, like a camera on a stabilizer. Because of this, the mantis's movements look unnatural, too smooth, too deliberate, as if the tiny predator is calculating the distance to the target well before the attack. But the mantis doesn't win by speed alone. Its main weapon is camouflage. The orchid mantis doesn't just copy a flower. To pollinating insects, it proved more attractive than actual flowers. Its body reflects ultraviolet light in almost the exact same way as plant petals. To a bee, it looks not like a threat, but like an ideal landing spot. The predator sits motionless, sometimes for hours, only swaying slightly, mimicking the movement of petals in the wind. And then, the flower suddenly opens and turns into a trap. Some species know how to rock from side to side, copying the movement of leaves. Others mimic dry bark, twigs, and even fungal growths. There are species covered in growths resembling moss. There are mantises resembling burnt leaves. They literally dissolve into the environment. The prey notices them only at the moment of the strike, and usually that is the last thing it manages to see. But the most terrifying part begins at night. In the dark, the mantis barely moves. It sits motionless while moths and nocturnal insects fly around. Its eyes function worse without light. Therefore, other systems come into play. Sensitivity to vibrations, air currents, the movement of shadows. Sometimes the mantis reacts before the prey even touches a surface. A moth is only approaching a branch, and in the dark, the legs suddenly snap open. A strike. Silence. And then, only the dry crunch of chitin is heard. Yet even such a predator is constantly under threat. Some species can hear the ultrasound of bats. Specialized organs are located on their chest, detecting high-frequency signals. Hearing an attack, the mantis abruptly folds its wings and drops like a stone, breaking the trajectory of the dive. Sometimes it falls straight into the grass and freezes. Completely. Even its antennae stop moving. In the dark, this is sometimes enough to vanish. And if the enemy is already too close, another program runs. The threat display. The mantis rears up on its hind limbs. The front legs fan out to the sides. The wings spread, revealing bright spots resembling the eyes of a large animal. The body visually inflates to nearly twice its size. Inside, the activity of the nervous system spikes instantly. The thoracic muscles tense to the absolute limit. More air flows through the spiracles into the body. The abdomen expands. The insect literally forces its organism into an emergency overdrive mode. And sometimes, this program glitches. The mantis can attack objects it is physically incapable of defeating. A human hand, a cat, a camera. It sees movement. A reflex triggers. The legs thrust forward. Sometimes the spikes even puncture human skin. Not because the mantis is brave, simply because its threat assessment system is incredibly primitive. Movement equals target. Attack. Only later does it become clear that the prey is too massive, but they rarely retreat. Even a tiny mantis can keep threateningly swaying before a creature thousands of times heavier than itself, as if the ancient program does not tolerate the very concept of surrender. And all of this would be less horrifying if mantises only hunted insects. But large species attack lizards, frogs, mice, small snakes, and even birds. Photographs exist where a mantis holds a hummingbird and eats its head. Usually it sits near a feeder or a flower. Total immobility. The hummingbird hovers in the air for just a second. Its wings beat dozens of times per second. Its heart operates at its limit. The bird is built for speed. But it is precisely this hovering that makes it vulnerable. The mantis waits for the moment when the trajectory becomes predictable and fires its legs. The spikes slip beneath the feathers and instantly pin the wings to the body. The leg joints clamp around the bird's ribcage. The hummingbird tries to break free with an upward jolt. The wings beat with frantic speed but cannot open fully. Then the bird begins to spin. It tries to use momentum. The beak strikes the mantis's head, but the hold is already locked. The mantis slowly pulls the prey closer to its jaws. Most often it chews through the area behind the eye or the base of the skull, because the bone is thinner there and the tissues are softer. First, the skin breaks. Then, the thin bone of the eye socket. The jaws enter deeper. The hummingbird is still twitching. Its heart keeps beating frantically. Its feet sunderingly clench. The wings try to open again and again, but the mantis is already eating the neck muscles and the brain. Sometimes the bird remains alive for several more minutes. An insect the size of a palm is capable of systematically killing a vertebrate animal of its own weight. And the strangest thing is how ancient this creature remains. Mantises existed about 300 million years ago. They are older than dinosaurs, older than even many groups of modern insects. And through all this time, their design has barely changed. Evolution rarely leaves an organism unaltered for so long. But in the case of the mantis, the blueprint turned out to be too successful. Nature had almost nothing to correct. The ultimate irony is that cockroaches are considered close evolutionary relatives of mantises. One common ancestor, two completely different survival strategies. Most insects survive through sheer numbers. The mantis chose a different path. Precision, patience, control, camouflage. It is not the strongest, not the fastest, and not even the largest predator among insects, but it is one of the most cold-blooded hunting mechanisms that evolution has ever engineered.